All right, so we heard from Rob in the Cucamonga Water Valley District as to how important this project is for him, and I wanted to get a little sense as to the science as to what's going on. So I'm here with David and Ryan. Guys, how you doing?
Good. Great. How you doing, Rob?
So what's going on here? What's we heard about the well and the contaminated well, and you guys are fixing it. Tell me about the science behind it.
So we're using naturally occurring bacteria that are naturally in the ground, and we're bringing them out of the water, or bringing the contaminant is being removed by these naturally occurring bacteria. The overall process starts at the well, of course. That's been contaminated over years of agricultural use. We pump up the water and we're bringing it up into this large reservoir, large buffer tank, and from that tank we feed our system. Our system really consists of 3 basins full of media that have hollow fibers in it that we treat, that contact the water and treat the nitrate out. After the water, the nitrate's been removed.
Where's that happen? It doesn't happen in here,
No,
right?
that doesn't happen in here. That happens in the 3 basins that that are inside of this large tank.
Okay.
The first 3 basins are filled with hollow fibers that'll have the bacteria will grow on them. And after the nitrate's been removed, contacted with that surface, the bacteria will also remove the dissolved oxygen in the water, and so we'll re-aerate the water. We'll bubble just compressed air through it, re-oxygenate the water. Then we're going to filter it, remove turbidity, any traces of bacteria, and then disinfect it, and then it becomes drinking water.
Huh. So what's you've got? I mean, it's a pretty significant structure here. How many different? You have little environment vessels, right? That the bacteria live in. So how many are in this system?
So there's enough room for 141 modules. They're hollow fiber. We deliver hydrogen through the center of these little tubes, and it permeates through the hollow fiber and provides a very large surface area for a thin layer of bacteria to grow. That bacteria takes the nitrate out of the water, the hydrogen out of our delivery mechanism, and voila, there we go.
So that's crazy. So bacteria is used in to process yogurt and cheese and beer. Okay, so I mean, bacteria is a naturally occurring.
There's good bacteria that are part of our ecosystem. They're in our bodies. They're providing good, useful functions for us all the time. All we're doing is providing them a place to hang out and thrive.
All right, so Ryan, this is where the bacteria are, and then it comes over to here, and we got a whole lot of stuff going on right here. What's all this equipment right there?
So the water's coming out of the well back off on this side. It comes into a flange there that hasn't been plugged in yet, but is about to be. And it's sucked in through that feed pump and forced into our basins. And once the water gets there, it's diverted equally through all of our hollow fiber membranes, and the water flows across the surface of this fabric of hollow fibers where the bacteria grow.
Okay, so from a purely scientific point of view, this method is so dramatically different than the methods we have traditionally applied to it, because we normally just put a bunch of chemicals in the problem, split off all the waste from the chemicals, and then ask to be treated. This process is completely different.
Yeah, this is a really neat melding of a lot of new and technology that's developed over the years, from the production of membrane modules to bacteria microbiology, understanding of good bacteria, how you can use them to useful benefit.
That's right, Rob. It's been used extensively in Europe, particularly in France, to remove nitrates from drinking water and convert it into harmless nitrogen.
All right, guys, thanks so much.
Thank you. Appreciate it.
Next, I head over to the engineering team to meet up with Lynn Todd to get a sense from him how the product design suite and Autodesk Inventor digital prototypes are used in the rest of the organization.